Hello everyone and welcome to our question and answer video on hydraulic and pneumatic systems. In this video, we will be answering some of the most commonly asked questions in MSBE exam on hydraulic and pneumatic system. Question 1. Enlist and explain in brief the functions of hydraulic oil in a hydraulic system. Following are the main functions of hydraulic fluid. 1. To transmit power. It is a basic functions of hydraulic fluid. 2. To lubricate the moving parts. 3. To seal gaps and clearances between mating components. 4. To dissipate heat generated by internal friction. 5. To prevent rust and corrosion of internal parts. Question 2. Describe essential properties of oils used in all hydraulic circuits. Important properties of hydraulic fluid are: 1. Compressibility. 2. Viscosity. 3. Stable viscosity index. 4. Demulsibility. 5. Foaming tendency. 6. Oxidation. 7. Heat dissipation. 8. Wear resistance. 9. Corrosion resistance. 10. Pour point. 11. Flash point. 12. Non-toxic. Now, let us see each property one by one. 1. Compressibility. C2 cylinders are shown in figure. One cylinder contains a gas and the other contains a liquid. If a downward force is applied to the piston in the gas cylinder, the piston will move down and compress the gas. If a downward force is applied to the piston in the liquid cylinder, the piston will not move. These we can say that liquids are incompressible in nature, hence they are suitable for precise motion control. Hydraulic oil should have low compressibility for better performance. 2. Viscosity. Viscosity is a fundamental property of hydraulic oil that plays a critical role in the performance and efficiency of hydraulic systems. It is a measure of the oil's resistance to flow and is determined by the molecular structure and composition of the oil. Viscosity is typically expressed in units of centistokes, cent, or centipoises, cp, and is often referred to as the thickness of the oil. Higher viscosity oils are thicker and flow more slowly, while lower viscosity oils are thinner and flow more quickly. In hydraulic systems, viscosity is important for several reasons. First, it affects the efficiency of the system by influencing the pressure drop across the system and the energy required to move the fluid. Second, it affects the ability of the oil to lubricate moving parts and protect against wear and damage. Finally, it affects the ability of the oil to transfer heat and maintain proper operating temperatures. To ensure optimal performance and efficiency of hydraulic systems, it is important to select hydraulic oils with the appropriate viscosity for the specific application. This may depend on factors such as the operating temperature range, system pressure, and flow rate. To select the appropriate viscosity grade, it is important to monitor the viscosity of the oil over time and adjust as needed to maintain proper performance and efficiency. This may include regular testing of the oil and the use of additives or viscosity improvers to maintain optimal viscosity under changing operating conditions. 3. Stable viscosity index. Stable viscosity index, 6, is a measure of how well an oil or lubricant can maintain its viscosity or thickness over a range of temperatures. The viscosity of oil changes with temperature, and oils with high stable 6 will show minimal changes in viscosity over a wide temperature range. Oils with a stable viscosity index are able to resist changes in viscosity due to temperature variations, which can lead to improved lubrication and protection for machinery and engines. Stable viscosity index is an important characteristic to consider when selecting an oil or lubricant for use in high-temperature applications, as it can help to prevent the breakdown of the oil and extend the lifespan of the equipment. Several factors, such as the chemical composition and additives used in the oil, can influence its stable viscosity index. The formula for calculating stable viscosity index is based on the kinematic viscosity of the oil at two different temperatures, typically 40 degrees Celsius and 100 degrees Celsius. The formula is 6 is equal to Lu, L 19, x 100. Where L is the kinematic viscosity of the oil at 100 degrees Celsius and U is the kinematic viscosity of the oil at 40 degrees Celsius. The resulting value of stable 6 is typically between 0 and 100, with higher values indicating a more stable viscosity index. Oils with stable 6 values above 95 are considered to have excellent viscosity stability and are often preferred for use in high-temperature applications, such as automotive engines and industrial machinery. 4. Demulsibility. It is the ability of a fluid that is insoluble in water or to separate from water with which it may be mixed in the form of emulsion. Or it is the oil's ability to release water. 5. Foaming tendency. When oil returns to receiver, it comes in contact with air above the liquid surface. The oil has tendency to absorb air or gas, which results in foam formation. Good hydraulic oil must release the air gas very quickly so that it does not form foam. 6. Oxidation. Oxidation stability is a chemical reaction that occurs with a combination of the oil and oxygen. Over time, fluids oxidize and form acids, sludge, and varnish. 7. Heat dissipation. An important requirement of the fluid is to carry heat away from the working parts. Hydraulic systems dissipate heat through the reservoir. 8. Wear resistance. Wear resistance is a hydraulic fluid's ability to reduce the wear rate in frictional boundary contacts. Anti-wear hydraulic fluids contain anti-wear components that can form a protective film on metal surfaces to prevent abrasion, scuffing, and contact fatigue. 9. Corrosion resistance. Two potential corrosion problems must be considered. One is system rusting and second is acidic chemical corrosion. System rusting occurs when water carried by the fluid attacks ferrous metal parts. Most hydraulic fluids contain rust inhibitors to protect against system rusting. And to protect against chemical corrosion, other additives must be considered. 10. Pour point. The pour point of hydraulic oil is the lowest temperature at which the oil will flow. It is an important property to consider when selecting hydraulic oils for use in cold environments or for applications that require low-temperature operation. At low temperatures, the viscosity of hydraulic oils can increase, causing them to thicken and become less able to flow freely. If the pour point of the oil is too high, it may not be able to flow through the system, leading to reduced system performance or even system failure. To ensure proper operation in cold environments, it is important to select hydraulic oils with a low pour point. Hydraulic oils with a low pour point contain additives that help to reduce the viscosity of the oil at low temperatures and prevent it from thickening. 11. Flash point. Flash point is a temperature at which liquid catches fire automatically. The flash point of good hydraulic oil must be as high as possible so that fire possibility nullified. 12. Non-toxic. Good hydraulic oil must be minimum toxic to human being working with them. Some fire-resistance hydraulic oils are highly toxic, which can cause occupational diseases. To ensure non-toxicity, it is important to select hydraulic oils that have been formulated with safe and environmentally friendly additives. Question 3. Enlist various ISO and SAE grades of hydraulic oils. The ISO, International Standards Organization, and SAE, Society of Automotive Engineers, grades are based on the main property of kinematic viscosity. It ranges from 32 centistrokes to 220 centistrokes. Higher the number of the grade, more the kinematic viscosity of the oil. The Standardization Institute's ISO, International Standards Organization. This classification applies mainly for use with industrial lubrication. According to the system, hydraulic oils are designated by the letters ISO followed by a number equal to the oil viscosity measured in centistrokes at 40 degrees Celsius, 104 degrees Fahrenheit, ISO VG 32, ISO VG 46, etc. SAE, Society of Automotive Engineers. Monograde hydraulic oils. Monograde hydraulic oils are designated by one number 10, 20, 30, 40, etc. The number indicates a level of the oil viscosity at a particular temperature. The higher the grade number, the higher the oil viscosity. SAE 10, SAE 20, SAE 30, etc. was specified at the temperature 100 degrees Celsius. These oils are suitable for use at high ambient temperatures. Viscosity of hydraulic oils designated with a number followed by the letter W, SAE 10 W, SAE 20 W, SAE 30 W, etc. was specified at the temperature 0 degrees Fahrenheit, minus 18 degrees Celsius. The letter W means winter. These grades are used at low ambient temperatures. Multigrade hydraulic oils. The first number of the designation specify the oil viscosity at cold temperature. The second number specifies the oil viscosity at high temperature. For example, SAE 10W30 oil has a low temperature viscosity similar to that of SAE 10W, but it has a high temperature viscosity similar to that of SAE 30. Question 4. Define the term neutralization number and lubricity. 1. Neutralization number. Neutralization number refers to a measure of the acidity or alkalinity of a lubricating oil. It is a measure of the amount of acidic or basic compounds in the oil that have reacted with an alkaline or acidic solution. The neutralization number is typically expressed in milligrams of potassium hydroxide (KOH) per gram of oil and can be used to monitor the level of acid contamination in the oil. A high neutralization number may indicate the presence of acidic contaminants in the oil, which can lead to corrosion, wear, and reduced oil life. 2. Lubricity. Lubricity refers to the ability of a lubricating oil to reduce friction and wear between moving surfaces. It is a critical property of lubricants that is essential for protecting engine and machine parts from wear and damage. The lubricity of an oil is determined by its chemical composition, including the type and concentration of additives and base oils. Lubricity is typically measured using standardized test methods, such as the high-frequency reciprocating rig (HFRR) or the ball-on cylinder lubricity evaluator (BOCEL). A high lubricity oil will have a lower coefficient of friction, reducing wear and prolonging the life of machine parts. We hope this Q&A video has been helpful in answering some of your questions about hydraulic and pneumatic systems. If you have any other questions or topics you would like us to cover, please let us know in the comments below. Thanks for watching.